Hello students. In my previous lecture, I introduced electrical braking of induction motor. So we have seen that there were three methods: regenerative braking, plugging, and dynamic braking. So in the previous lecture, I explained in detail the regenerative braking, where the energy stored was sent back to the source. Now in the plugging, or you can say reverse voltage braking, we have to change the terminals. We had seen this method in DC motor also, when we just interchange the polarity of supply to implement this method of braking. So here we have, suppose this is a wound rotor induction motor, and it is normally running like this. We have given three-phase supply to the three terminals of induction motor. Phase A is connected to phase A, phase B to phase B, and phase C to phase C. And the motor is normally running in one direction, and the corresponding characteristics will be somewhat like this. If you plot the characteristics for the whole range, it is like this. So in this range, it is in the motoring mode, and this is the braking mode, when the speed is negative and torque is positive. So this is the normal characteristics of the induction motor when it is running like this. Now when we want to go for braking, we have to move. Suppose this is the load torque connected here, and the point A is the operating point, and the motor is running at a speed omega ma corresponding to the point A on the characteristics. Now we want to stop the motor, or we want to reduce the speed of the motor. What you have to do here, actually, we have to interchange the terminals. You have to change the phase sequence. In one phase sequence, the rotating magnetic field will flow in one direction, move in one direction, and in the other phase sequence it will rotate in the other direction. So what you have to do is, we have to interchange any of the two terminals. So here I have shown that phase A is now connected to B and B is connected to A. So we have interchanged these two terminals. You can change any of the two terminals. So this will actually, what it will do, it will change the direction of rotating magnetic field. So if you do this, then characteristics will be like this. For negative phase sequence, the speed, synchronous speed will now be equal to minus of the original speed, and this is the characteristics for the negative phase sequence. So this will be reverse motoring operation, and in this case it will be reverse, it will be forward braking operation. So with the reversal of this, what happens is that for the positive phase sequence, I call this as positive phase sequence and this as negative phase sequence. For the positive phase sequence, the synchronous speed was omega ms minus omega m upon omega ms, where omega m is the speed and omega m is the synchronous speed. Now with the reversal in the terminals here, what happens is that speed doesn't change instantaneously, speed remains the same. Only thing that changes is the direction of the synchronous speed or rotating magnetic field. So instead of plus omega ms, you have to write minus omega ms minus omega m upon minus omega ms. So if I have just manipulated and added here minus twice omega ms and added here plus twice omega ms. So just divide it like this: minus 2 omega ms upon minus omega ms plus, just simplify it, omega ms minus omega m upon minus omega ms. This slip you may call as slip positive. So this is nothing but 2, and this is the slip that was for positive value. And this slip positive is close to 0, it may be 0.04 or 0.06 like that. So that approximately you can say that it is close to 0. So what happens to the slip for negative phase sequence? It is equal to 2. It is close to 2. So this means that the slip of the motor will change from a value close to 0 to a value close to 2. And you know that while starting, when the motor is started, then the slip is equal to 1, and the motor draws a heavy current, maybe 5 to 6 times the full load current of the motor. When the slip is 2, this means that the motor will draw even higher current, maybe say 10 times or 12 times the full load current of the motor. So this is the problem. But if you do this without adding any resistance here, then the characteristic will be identical. Only thing is that it will be in the reverse direction like this. So this is the characteristics, and what happens is that speed doesn't change instantaneously. So as soon as we reverse the phase sequence, the speed remaining same, the operating point will shift from A to this new operating point that you may call as point B. So the torque will become negative. The direction of rotating field has reversed. So the torque will always be the direction of rotating field. So this torque will also be negative. So because of negative torque, the motor's speed will decrease, and as per the characteristics, the starting torque, the braking torque will increase, and it will be this much value when the motor comes to 0 speed. So at 0 speed also torque is there, and the motor will accelerate in the reverse direction and operate somewhere here. So if you want to stop the motor, you have to disconnect the supply as soon as the motor speed becomes equal to 0. So with this, without any external resistance connected there is one problem, that the braking torque TB is not very high, and the current drawn is very high. Current drawn is may not be permitted for the motor. So this current is very high, but the torque generated is less. So if you are having a wound rotor motor, then you have provision of adding resistance in the rotor circuit. So rotor terminals are directly not short circuited. Whenever you do these changes, you have to make a change here also, that you have to add suitable resistance RB in the 3 phases of the rotor winding. So this change has to be done. So if you add the resistance, if you recall, if you add the rotor resistance, the slip for maximum torque changes, but the maximum torque remains same, and starting torque changes like this. If you add resistance like this, further add the resistance, it can be like this. So if you add the resistance, the slip for maximum torque will increase, but the maximum torque remains same. So starting torque will also change. So with this negative direction also, the characteristics for suitable value of RB will be like this. For lesser value of RB, it could be like this. So this is the new characteristics. So this is not the new characteristic because you are directly not short circuiting it, rather you have added some resistance here. So the characteristic will be like this. So the new operating point will not be B, it will be some, say, I will call B with resistance RB. So this is the new operating point, and you can say that the braking torque generated here is, as per this figure, is double the braking torque produced without any external resistance connected here. So more braking torque means the motor will more quickly decelerate, and the speed will decrease quickly, and it will come to 0 speed at this point. And if you want to stop the motor, you have to disconnect the supply as soon as the motor speed reaches 0. So this is what is known as the reverse voltage braking or plugging. Plugging means you have just interchanged the terminals. But this complication is there. You have to add resistance also to limit the current drawn by the motor. Just after you have made this change here. So this is what is known as the plugging or reverse voltage braking. Thank you for this.